All right, ready to go?
Yep.
Okay, class. So today we're going to be learning about perimeters and areas of polygons. In our last session, we learned what a polygon was. So we're going to get into the nitty-gritty of them this time. All right, we're going to get into terminology first. So we're going to go over some definitions. Our first definition is perimeter, which is the sum of the lengths of a polygon's sides. The next definition is linear units, which is what perimeter is measured in, such as inches, feet, or centimeters. Area, the product of length and width. The next one is square units, what area is measured in, such as square inches, square feet, or square centimeters. And lastly, composite figure. And a composite figure is a figure made up of triangles, squares, rectangles, or other two-dimensional figures. So first we're going to talk about perimeter, and we have two examples. The first example is a four-sided polygon, and all of the sides are equal and equivalent. So what we're going to do is add all sides up, so 6 feet plus 6 feet plus 6 feet plus 6 feet, which is 24 feet. So that's a pretty straightforward example of perimeter, just for a basis. And for our next one, it gets a little challenging. We have to first find the missing length of the remaining side. So to find that length, we're going to take the side of 3.4 centimeters and subtract it by 2 centimeters because it'll add up to the full length of 3.4. And that is going to give us 1.4 centimeters. And then after, you're going to add all these sides up, and it's going to come out to 24.8 centimeters. Does that make sense?
Yep.
Okay. All right. So perimeter is pretty straightforward. So we're going to slide into area. Some of the formulas that we're going to need to know are of a rectangle, parallelogram, trapezoid, triangle, and a kite. So the rectangle form is area equals length times width. A parallelogram is going to be area equals base times height. Trapezoid, area equals half the height times little b plus big B. The triangle is going to be area equals half times the base height. And a kite is going to be area equals half times the lengths of one side and the lengths of the second side, which will be the base. So we're going to go over some more examples of area. The first example we have is a square. So we're going to use the formula base times height. So we're going to do 24 inches times 24 inches, which is going to give us 576 inches. The second example is a parallelogram. So we're also going to use the base times height formula. So that's going to be 15 inches for the base and then 8 inches for the height, which is going to give us 120 inches. Now this one, we're going to use a different formula because it is trapezoid. So we're going to use area equals half of the height times little b plus big B. So in this case, the little b is 8 feet and our big B is 14 feet. So we're going to add those two together, and then we're going to multiply that by our 6 feet, which is our height. And after that's all done, we have to multiply it by half, which is the same as dividing by 2. So our answer is going to come out to be 66 feet. Any questions?
None.
Okay. Moving forward. All right, here are a couple more examples of a triangle and a kite. So our first one is a triangle. And the formula we're going to use for that is area equals half of base times height. So what we're going to do, the base is 14 meters, and we're going to multiply that by our height, which is 10 meters, and then we're going to divide it by 2. So that's going to be 70 meters, pretty straightforward. And then for the kite one, this where it becomes a little more tricky because we have to do a little extra math. We're going to take the lengths of 9.2 meters and then the other side, which is 9.2 meters. We're going to add them together, which is 18.4. And then we're going to take the 6.9 meters and the 13.8 meters and combine them as well, which is 20.7. So after we have found that, we're going to multiply those two numbers together, which is going to give us 380.88, and we're going to divide that by 2. So that's going to give us 190.44 millimeters, or meters. All right, so now we're going to get into a word problem. A motorcycle driving test requires the driver to stop with the front wheel of the motorcycle inside a rectangular box drawn on the pavement. The box is 60 inches long and has a width that is 24 inches less than the length. Find the perimeter and area of the box. All right, so the two things that jump out are the numbers. So what we're going to do is draw a box first. So we're going to, we know our length is 60 inches long, and the width is going to be 24 inches less than that. So how are we going to find that, Ben?
We're going to subtract 60 by 24, right?
Correct. And we know that it's a rectangle, so we know that each two sides are going to be parallel to each other and equal.
Yep. So there's going to be two sets of lines.
Exactly. So let's go to the next slide. So there's our 60 feet, and then there's our 60 feet minus 24.
Yep. That would be 36, I think. Right?
Correct.
Yep.
Correct. It's 36. So now to find the perimeter, what are we going to do?
Going to add up all the sides. So we
Correct.
got 60, 36, 60, 36.
Yep. Which is going to give us 192 feet.
All right.
Easy enough. And now we're going to try to find the formula of the area. So what are we going to do?
Just multiply one side by another side. So like length times width, which here would be 60 by 24, and then that'd be 1,440 feet.
Correct.
Or a square.
All right. Awesome job.
All right. Gonna jump over to mine, I guess, right now.
Okay.
All right. So for my presentation, I decided to work on surface area, as you can see by the label. So helpful vocab to know about surface area. There are lateral faces, bases, and net. Lateral faces are basically surfaces on an object on its side. So like if you think about a 3D figure, there's like 6 faces on a cube. And then the bottom face would be a base. The top would also be a base. So that would be, there's the 2 bases there. And then all the sides going around would actually be lateral faces. And yeah, I already talked about bases. Net. So a net is basically when you split open a 3D figure to make more sense of it. And I have some more examples in here as we go. So basically, surface area is referring to the total area of a 3D object, or 3-dimensional. It can be abbreviated in a formula using a capital S. Finding the surface area of cubes, rectangles, and triangular figures are all done differently, and there are other ways of finding the surface area. Surface area can be simply found by the addition of each face of a figure. So when you're going to find the surface area of a cube has 6 sides, and they're all just about the same size. They're all equilateral. So a breakdown. So a way I would approach this, personally for me, is you already see the 3 by 3 on the cube. So we just had to find the area of that, which we learned in a Jordan's lesson. So we go 3 by 3, that's 9. And then that would equal area. And then because the cube has 6 sides, you multiply 9 by 6 and get 54 centimeters squared.
Gotcha.
And so another way you can remember this is I kind of just explained a way in how I would do it, but you could do it. There's a formula for it. It's like S equals 6a squared, which a would just be the area you get from one of the first faces. But I think if you take the time to kind of work each individual piece out, I think it helps it quite a bit when you're trying to understand it.
Definitely, that's what I would do.
And yeah, you can see another example down the bottom where S equals 3 squared, and then that makes 6, 9. and then it's basically just the same thing, but a little more simpler, and it's more streamlined, I guess. Um, so finding the surface area of a rectangle is a little bit different. With this, you now have to worry about the two different parallel sides with the left and right, up and down. And so if you use this equation, um, the bases, the top and bottom, you would see 2 lengths times width. And now because we're working with 3D figures, we're not only working with length times width, we're also working with height. So when we're calculating the lateral faces, we will start using height with our calculations. And I'm going to show you what nets look like. So here's what a net looks like. Um, if you look right on the lateral faces part, that's basically, if we go back here, that's just the first face that's looking right at us. And then a net is just, a split open, like what we have here, it's a split open rectangle. And you follow along, there goes, for the top base, there's length times width. You can do the same thing for the bottom base. Lateral faces, there's width displayed on the top, because that's what's going back in the figure. And the length is just kind of matching up with the length of the base on the top. And then the height is just the height. So if you go back here real quick, there's the thing is 2 times length times width plus 2 times length times height plus 2 times width times height. So what we're going to do is we're going to take let me see this real quick. So for our shape, we had 10 centimeters is the height, 20 centimeters is the length, and 7 is the width. So we go here, right here one more time, 2 lengths times width, and that would be the 20 by the 7. And kind of with the rest of the thing, you just want to multiply the numbers you have to multiply together. And so with that, we get 2 times 140, 2 times 200, and 2 times 70. So you got 280, 400, and 140, which would equal 820 centimeters squared. And yeah, it's just a lot of like plugging in where. Now I'm going to go into pyramids, because pyramids are quite a bit different than your normal square rectangle figure. With this, you kind of just want to calculate the area for a triangle. That's essentially what we're doing. So we're taking one side of this, doing the area equals base times height. So it'd be, or half, it's half base times height, right? So you go, because this is 25 feet, you go 12.5 feet times like 32. And that's how you get that. And then you just have to worry about calculating, because it is a 3D pyramid, pyramids in the 3D, they have square bases. So you also have to calculate that into effect as well. And basically just take the area of the triangle and then just multiply it by 4, and then you can get the rest of it. I'll show you another bit about it right here. As you can see, I had a little fun with these. So yeah, half of 25 would be 12.5 times 32, which would equal 400 feet squared. I'm not sure why I used feet in my example. I could have used a much more reasonable number, or measurement, because that's a really big pyramid. But so yeah, with the square, you get 25 by 25, which would make 625 feet squared. And then you'd only have to multiply 400 by 4 to get the area of all the triangles in the shape. And then you just add the squares. And then you get your total of 2,225 feet squared. Yeah, I wrote a little note here. For solving a lot of different shapes, you just need to know how to logically see and piece together the lengths, widths, and lengths, and heights. I'm sorry. You need to refer to the area formulas from time to time for different shapes and more complex 3D objects you are trying to find the surface of. For me, just knowing half base times height is like the area of a triangle. Knowing kind of the base formulas can help quite a bit.
Right. It's definitely a lot of memorization of the formulas, I think.
Yeah. At least with this, this kind of stuff. So for an example, I only really have one big example. All the rest of kind of just been walking you through how to do problems or how to, find the thing of area of shapes or
Mhm.
surface area of shapes. Sorry. Um, so this is the tent problem that you might see on, tests or other, just other places you might see it. So you and your friends will go in camping, but you need a tent. It costs a lot to get a large one, so you decide to cut corners and make your own because it's a lot cheaper. So cloth costs 75 cents per square meter, and find the total cost of the tent. So with
Hmm.
this, I'm just going to skip ahead here. I have the example here again. Basically, we're just creating another net, but this time we have to worry about rectangles and triangles at the same time. Which, as long as you remember, formulas like a rectangle, squares like areas, like length times width, triangles half base times height, you could just add it all up at the end and get your final result. It's mainly just
Mhm.
about understanding how the shapes break down and then merge together as like an actual like prism. Which
Right.
also I should have put that in there. Prism's basically just like a 3D shape that light can go through. But in this case, we're just kind of using like a prism to represent a tent.
Mhm. I really like how when we fold it out, it's just more clear to see.
Yeah.
I feel like a lot of students sometimes look at 3D objects and they're like, nope. So I
Yeah.
really like the layout of that.
Thank you. Yeah. It just makes more sense for me. Like it's like you could do it obviously by calculating with the shape itself, but if you actually like take the time to make the net of it, I think it just helps you understand it a lot more, and it's a lot you're gonna screw up a lot less as well.
Yeah, definitely.
So with the triangles, I'm only going to be doing one of the triangles on one of the lateral faces, or the lateral rectangles. So, and then at the end, I'm going to multiply them by how many there are, which is another way of how I kind of do things. Is just, you know, just multiplying how many you have of something at the end. If you have like multiple of like one thing, especially with like surface area, it just helps quite a bit.
Mhm.
So yeah, with triangles, we got half 2.3 meters. Multiply that by 3.2 meters equals 3.68 square meters. And with the blue rectangles, there one side's 4, the other side's 3.4. Multiply those, you get 13.6 square meters. Which yeah, there's two of those, but I'll show you what I'm gonna do in the after this. With the base rectangle, there's a length of 4 by 2.3. So multiply those, you get 9.2 square meters. And another thing that will throw people off too is if you don't consider like the bottom face of this a base, you might just think of it as another 3.4 by 4 triangle, which would actually screw up your math or confuse you down the line when you're
Mhm.
trying to like find the right answer. And then what I did now is I'm just multiplying the triangles by 2, the rectangles by 2, and then just leaving the base rectangle by itself or multiplying it by 1 if that helps. And then
Mhm.
in the end, I end up with 43.76 square meters. But then now for the cost, we have to say, okay, so per square meter, it's 75 cents of fabric. So multiply that by 75 cents, and you got $32.82. And I
Hmm.
don't know about you, but that seems like a pretty cheap tent.
Oh yeah, I'd prefer that one over
Hmm.
any other one.
Yeah, it really depends. I don't know. I'd imagine if you made tents more often, you'd probably get a lot better at it. But I don't know. Making a tent itself does sound hard, but I mean, if you just like looking to, cut corners, definitely see
Mhm.
how you can make one yourself. I just have no other notes that I'd wanted to add. So when you're finding the surface area or area of anything really, is just remember to square your units because all the measurements of surface area are squared because length times width or base times height use the same units. So basically, when you're multiplying anything, you're also multiplying the units themselves. So like say if you get like 2 centimeters times like 4 centimeters, you're gonna end up with like 8 centimeters squared because the centimeters are also multiplying.
Mhm.
And whenever you like multiply, like even just a variable or just anything that isn't represented by a number itself, it just ends up being squared.
Mhm.
Um, Another recommendation is be sure to break down complex or even the simplest shapes into nets. to better understand the whole picture going if, you're having trouble or anything, or you're just having one of those, days where you're just like, I don't want to take the time to do it. I mean, I'd strongly urge you to, like, even if it's an easy problem, just kind of work it out and, have a little fun with it. Calculating surface area is essentially just calculating the area of each shape in a prism, and then adding them all at the end. So it's not too difficult, but it definitely can hit you if you don't conceptually see it as how
Yeah,
it is.
definitely.
Yeah, and that's it for me.
All right. I think we're
We're
golden.
good. All right.
All right.
Thank you
Till
guys for
next
listening,
time.
and yeah, until next time.